Okay, so we were finishing up logarithmic functions. We had already simplified, right? We've found values based on if we have the log base and the exponential base be the same. We know the exponent is our answer, yes? We also looked at exponential functions. So we know that an exponential function, unless it's been translated, will start at the point 0, 1, correct? And this is your basic shape. It has a horizontal asymptote, yeah? We talked about the fact that the exponential function and the logarithmic function are inverses, and therefore this had a horizontal asymptote. The logarithmic function has a vertical asymptote, correct? And the point 0, 1 is now 1, 0 for a logarithmic function, yeah? And so this is the general shape of your logarithmic function. It will approach that vertical asymptote and go up to the right forever. Yes? Okay. So based on that, let's look at your graphs. Remembering that this is the same thing as log base e, correct? Natural log and log base e are the same, yes? So there's two ways of thinking here. You could change that to exponential form to graph it, meaning we could take e to the y power, and that would equal x, right? And so if we were to look at it that way, we would be plugging a number in for y and solving for x. Do you agree? So if I plug 0 in for y, anything to the 0 power is just 1. And so that's where that point 1, 0 comes from. Everybody agree with that? If you were to plug in 1 for y, you would get e to the first power or just e. Do you agree with that? Which is approximately 2.7. So if you think of it that way, you would go right 2.7 up 1, and you would have a point at E1. Yes? And if we plugged in -1, remember that negative exponent, to get it to go away, we move that to the denominator. So that would be like 1 over E. Or 1 divided by 2.7, which would be approximately 0.3-ish. And so what we would talk about there is 1 over E and down 1. You'd have a point here at 1 over E, -1. This would be your graph of that function.
So how many points do we actually need?
On most of these, 2 points would be sufficient, as long as you know what's happening to the other side of it, right? Sometimes even 1 point would be sufficient. So, for your analysis, let's just talk about everything we know about functions. Well, first thing, if we're talking about the domain, our domain and range, everything we do at this point is pretty much in interval notation. Do you agree? Unless it's like a value, then it's obviously just that value. But your domain would be starting at 0 and going to infinity, right? 0 is not included in that. Do you agree? Your range would be what?
-82.
Right, it goes down forever, it goes up forever. This would be continuous. Specifically on its domain. Right? It's not like it goes left and right forever, but it is continuous, yes? It increases. Goes up from left to right. It's unbounded, meaning the range is -infinity to infinity. There is no extrema. It's also, there's no symmetry. It doesn't reflect the x-axis, doesn't reflect the y-axis, doesn't rotate around the origin. There's a vertical asymptote. At x equals 0. The only other thing there that I can think of would be in behavior. And so typically within behavior, we look at as x goes to negative infinity and as x goes to positive infinity, right? But the in behavior on this one's not going to go to negative infinity. Where is it approaching?
0.
Right. So when we look at our in behavior on this one, we're talking about as x approaches 0 of the function. And what's happening to the function there?
It's going negative.
And the other in behavior would be as x approaches positive infinity, correct? And so as x is going to the right, the function is going up. Agreed? Okay. It says describe how to transform the graph of f of x equals natural log of x or y equals log base 10 of x into the graph of the given function. So first of all, our parent function here would be what? Y equals natural log of x, yes? So what is this right here plus 2 inside tell us? Yep, it's going to go left 2. Remember your transformations from the last unit, yes? So our vertical asymptote, would it have moved? Yeah, our vertical asymptote was x equals 0. What's our vertical asymptote now?
-2.
X equals -2, right? And so here at -2, I would have a vertical asymptote. So that's something that should be graphed. And then we normally have a point at 1, 0. Do you agree?
Mhm.
We would move it left 2, and now it would be at -1, 0. You could do this E1 and move it left 2, but you'd have E minus 2, wouldn't you? And so that's why it doesn't necessarily make sense to have more than one point here. We know that this goes down, and this is going to go up and to the right. Agreed? So when you're dealing with E, it doesn't necessarily make sense to move that left 2 and actually write that on there. It'd be approximately 0.7, right? 1, if you wanted to put a point on there. Does that make sense? Okay, looking at this one. To start with, we know that the parent function is y equals natural log of x. Agreed? But we've got some things going on inside of here, don't we? So I would say, first of all, -x plus 3. But then also, in order to discuss horizontal translations, that x has to be positive. So I would rewrite this as natural log of -1 times x minus 3. So the first thing we look at is that -1 inside the function, right? And so that -1 being multiplied inside the function, what does that do? Reflects what? Y-axis. So the one way to think about that is, you know, x squared. If you have a negative x squared, it flips it upside down, right? And that negative would be on the outside of the function. Does that make sense? So that's the one that I know that if it's a negative on the outside because of x squared, I know it flips it down. If it's inside, then I know it's going to reflect the other way. Does that make sense? Okay, so here the minus 3, what's going to happen there?
Right 3.
So it reflects the y-axis and moves right 3 units. So does that affect the vertical asymptote? Yeah, your vertical asymptote is at 0, x equals 0, right? Reflecting it does not affect it. But moving it right 3 means I would have x equals positive 3 as my vertical asymptote. Everybody agree with that? Okay, so we normally have the point 1, 0, yes? Everybody agree? If I reflect it, I would now be at negative 1, 0, correct? But I have to move it right 3, so it's now going to be at 2, 0, yes? And so if you were looking at that point E1, when you reflect it, it would be at negative E1, correct? And so it would be over here, and if you move it right, you know it's going to be still up here, yes? So this is still going to go up and to the left, and this is still going to approach that vertical asymptote. Everybody agree with that? Okay, let's talk about the function log of x. We know that is base 10. Do you agree with that? Yeah? So no matter what the base is, our first point is going to be at 1, 0. Do you agree? Think about this. If you did 10 to the y equals x. If I plug in 0 for y, I get 1 for x, right? That's where that 1, 0 comes from. Yes? The only other one that would kind of make sense would be if we did to the first power, 10 to the first power is 10. So we would have the point 10, 1. And that would be a really good point, or 1/10 negative 1, yes? And so it would look like this. You're still going to have that vertical asymptote at x equals 0. Do you agree? You can see the general shape is going to be the same as the natural log of x. It's just maybe not quite, it's a little flatter on the top. Does that make sense? A little steeper as it goes down. So, looking at C, we know our parent function would have to be y equals log of x, yes? What is the 3 doing? Somebody's saying it under their breath, I heard. Vertical stretch by 3. Yeah? And if we're talking about vertical, we're talking about y coordinate. Do you agree? So that vertical asymptote, does that change? It's not moved left or right, is it? So that vertical asymptote is still going to be at x equals 0, yes? The point 1, 0, is that going to change? If you multiply your y coordinate by 3, 0 times 3 is still 0. So we're still going to have that point 1, 0. What would change is that point at 10, right? So instead of 10, 1, it would be 10, 3. And so putting that 10, 3 on there is pretty important because that shows me that you actually do know what a vertical stretch would do. Does that make sense? Questions? You can see there that this would be flatter here, so it did stretch it vertically. Yeah? Looking at D. Again, our parent function is what? And so what does this 1 do? Yep, shifts up 1. So my vertical asymptote, has that changed? So my vertical asymptote is still x equals 0, yes? And over here I should have added that on here. The vertical asymptote is still at x equals 0. I graphed it, but I didn't write it down. So here I still have this vertical asymptote at x equals 0. My point that's normally at 1, 0 is shifted up 1 to 1, 1. And the point that's normally out there at 10, 1 is now shifted up 1 and would be at 10, 2. So this is still going to go down and to the right, or down into the left towards 0 and up and to the right, correct? Questions? So labeling these points really is what tells me that you know what you're doing. Do you agree with that? Okay, because your shape is very similar. Questions on this? Do we feel okay here? All right.